Now, we really can't be talking about authentication in your network without bringing up 802.1x. Cisco certainly believes this. That's why 802.1x makes it to your routing and switching blueprint, but with an emphasis on the written exam only. Let's go ahead and cover in this nugget the information you would definitely want to know. There are three ingredients when we're utilizing 802.1x. There is the supplicant. Now, I'm a curious fellow, so I quickly grabbed Webster's dictionary and learned that a supplicant is a word meaning to beg. Ah, interesting. So this individual is trying to beg to get on our network to access some particular resource. In comes the authenticator. Notice this is our Cisco switch. The authenticator takes the information from this supplicant and passes it on to an authentication server. That's right. Think a Radius server. The Radius server can then say to the authenticator, yes, this person is absolutely cool, let him in. The authenticator can then let that individual in so they can go access whatever particular goodies that we want them to access. So it is three ingredients in this particular process. And since we're dealing with an authentication server, you immediately begin to envision the configuration on the authenticator, don't you? Sure, we do AAA new model. Of course, we set up our Radius servers. Then we can go ahead and put those Radius servers into a group. So if you examine my nuggets on AAA in this particular course, you get the foundation of what you would be setting up to make 802.1x work. Now, you might be thinking about a related type of technology that would allow someone that wants to get onto the network. Think about the point-to-point protocol. Sure, it was often used in dial-in environments only, but then it started being used over Ethernet. And the issue with PPP is that from a security perspective, from an authentication perspective specifically, it would be limited to the combination of a username and password. And that's exactly how it was built. So the designers of this technology, when it comes to really getting it done, decided that they needed to move beyond PPP. Well, to modify PPP in a really cool way. And that brings us to the extensible authentication protocol. When we say extensible, think flexible. So that if the user wants to use username and password, they can. But if they want to use a token, if they want to use a certificate in order to prove their identity, they can. So extensible is a key word when it comes to EAP. Now, as far as communications go between the authenticator and the authentication server, this is, of course, where we have Radius messages being utilized. So, extensible authentication protocol is so great for the supplicant to communicate to our authenticator, and then Radius can take over in the communications channel. This is so flexible, as we mentioned, for different supplicant type authentication schemes, and it's also flexible as far as this is a wired technology that we can utilize, or it is perfectly appropriate and often utilized in wireless environments as well. Now let's focus our attention on this particular authenticator switch port itself, where this supplicant is making the connection. There are two states that we deal with on this port. We are initially in what is called an unauthorized state. When you're in the unauthorized state, obviously the supplicant cannot communicate through to access the internet or other LAN resources, but protocols like Cisco Discovery Protocol and Spanning Tree Protocol are going to be permitted on that particular port just fine. When we transition to an authorized state, and this is because, of course, the supplicant successfully communicated using EAP with the authenticator, and the authentication server used Radius to say this person is indeed authorized, then we get our authorized port state, and all of the traffic can flow. By the way, this technology can be used for data VLAN traffic. It can be used for voice VLAN traffic. In fact, that's what I want to wrap up with here, is talking about the restrictions that are on 802.1x functionality. This needs to be configured where we connect as a switch port. In fact, it cannot be a dynamic access port. So we want to configure it statically in order to function properly with 802.1x. And also, we can't do things like span and rspan on that particular port, as you might guess. If the VLAN that you have assigned to that port is deleted or is disabled, then obviously that's going to kill the 802.1x functionality and force you into an unauthorized state. What's interesting is you can change the VLAN, and that would be transparent to 802.1x. A great scenario where you see that is where the authentication server is actually set up to change the particular VLAN based on the particular supplicant that comes in. 802.1x can handle that just fine. The 802.1x feature takes place and sends you into an authorized state, and then your layer 2 and layer 3 features that you might be doing in addition to 802.1x can kick in. Please note, of course, it's 802.1x that is controlling things with the port prior to the additional layer 2 or layer 3 features. So while we won't be configuring 802.1x in our lab exam, I would like you to see the commands that are involved from a written perspective. It'd be nice to identify them if we ever needed to. AAA new model, no surprise. Set up the Radius server, no surprise. And then AAA authentication, this time we specify .1x, and we want to by default utilize Radius for these purposes. Then you see something interesting. In global configuration mode, we say that we want .1x to be able to control authentication against this system. We, of course, set static access mode under the port where our supplicant's going to connect. Then we use our .1x port-control command. There's actually 3 options here. Auto would be the typical setting where we are going to have the supplicant come in, send the credentials. We're going to check them out against the Radius server, also known as our authentication server, and then we are going to transition the port from unauthorized to authorized. You can use 2 other options here. You can force authorized, and that's literally the command, and this does what it sounds like it does. It lets everybody in. Or you can do a force unauthorized if temporarily you want to ensure that this port allows no supplicants into the network. So of course in this nugget we dissected mainly the theory of 802.1x so that we are armed and ready for success in the Routing and Switching CCIE written certification exam. Before we wrap up, a quick comment on a gotcha, and I'm going to make sure, thanks to my flashcards, that you don't make this mistake. But as you might guess, a very common mistake is to confuse these 2 terms right here. The authenticator versus the authentication server. Remember, the authenticator is our Cisco switch, and the authentication server is our Radius server. You gotta drill that into your head because those terms are so similar. It would be very simple to confuse those in your written exam. Well, as always, I sure hope you found this nugget informative, and I'd like to thank you for viewing.